Hey, in this video we'll be talking about random numbers. How do we make random numbers in C++? Well, there are a couple of ways to do it. So I'll show you the first way, which is one that I think is pretty widely understood, but it comes from the C language. So that usually means there's a better way to do it in C++. So let's take a look. In Visual Studio, I have just my normal boilerplate here for a new project, and there is a C library called C standardlib.h. I can include this myself. Actually, if it's the C library, it's standardlib.h. If you're doing it as the C++ version, that's the same exact header, just the way that C++ has standardized it, then it's just C standard lib. Either way, same file. This gives us access to the rand function. And technically, I think this is included in IOStream anyway, so I'm not even going to need this line, but that's where it comes from. So this rand function, I can call rand and it will generate an integer. If I look at its declaration, it's really just that. It's just returning an integer. So if I want to use it, my random number is going to get from rand, and I can print that out. Random number. There we go. Try it out. Okay, computer's being a little slow. 41. All right, great. Let's try it again. 41. Okay, wait. 41. All right, so there's this interesting thing about random number generators, that there are two different kinds. One is called deterministic, and the other is non-deterministic. Deterministic. And so these are things you have to think about when you're deciding on random numbers for, say, a game. Determinism means that you can predict what is going to happen. Given the same inputs, you should have the same outputs. So the inputs for my program right now, I'm really like, if I'm looking at rand as a random number generator, there's no inputs that I'm really giving it. So let's just say whatever its default input state is, it's just using that. And it's using that same thing every time I run the program. So I am getting the same exact number every time. And worse, let's see, let me grab this and do this a few more times. All right, there we go. So 4 numbers. Okay, 41, 18,000, 26, 500. And you should expect this is the exact same numbers every time I run the program. So that's because rand is deterministic. Determinism can be a useful property. If you think about non-determinism, non-determinism means that something out of your control affects the outcome. So you can't reliably predict what the numbers are going to be. And for random number generators, it sounds like non-determinism is better, but it usually isn't. You don't really, as a game designer, want non-deterministic randomness for the most part. There are some places where it comes in handy. Let's just take one example of why you would want determinism. So consider recording gameplay for some sort of replay mode in your game. You could record a video and then the player is allowed to like look at that video again, but you do lose a lot of stuff in that. So like a video doesn't have event information or the scores at any point during the game. You can't orbit the camera or pan it around to look at different parts of the map or whatever. So you're really just stuck watching what one person might have seen while they played the game. But you can't actually explore the game while it's being played back. Another approach, something more flexible, is to record every input that ever occurs. So like the player's key presses, joystick values, all that stuff for every frame. Now it sounds like a lot of work to record all of that input, but if you do that, then you can just run your regular game code and feed it the recorded input data instead of the usual input. And there are so many benefits that you get out of that. You get this replay system that you can explore, that you can move the camera around. It's like you're playing the game and you can freeze the action at any time, move forward and backward through the action. And besides like those benefits, you're likely to get a smaller recorded file size too. Video files are pretty big, relatively speaking. But what about random events? If random events happen during your playback, if they're really random, non-deterministic, then wouldn't it affect the outcome of the replay? That will mess things up. So that's why determinism is so good. There are places where you want the same result over and over again, but you want to be able to control that. You want to say, okay, well, let's start the random number generator at this certain part, the certain place in its generation algorithm, and every time that we replay the scene or whatever was recorded, we're going to start at that same place again. And then you can play back the inputs, and every time the system is asked for a random number, it gives it the next one. So it can be deterministic. That's really, really good. So there's nothing wrong with RAND being deterministic. There is a way to make it slightly less deterministic, I guess, closer to non-deterministic, if you seed the random number generator. So let's do srand, and we can seed it. We can say 5 or 5,000. It really doesn't matter that much. This integer is kind of like the starting place. If 0 is the default starting place, I'm telling it, well, start at 5,000 instead, and then give me some random number based on that. And I'll seed it to start at a different spot in this sequence. So let's see. We get 16,000, 10, 16,000, 27,000. And if we run it again, 16,000, 10, 16,000. So it's the same thing. It's still deterministic, but we have seeded it to start in a different place. If we really wanted to make that less deterministic, we could change this seed value. And a common one you'll see online, if we just keep up with this C language theme, there's a C time header, and you can do time. What does this take? Pointer null. Okay, so something like that. This is the C way of writing it. And so this way, it will seed the random number generator based on the clock time, 10,000, 13,000, and it'll do it differently every time. So sometimes that's nice. And so, yeah, either way, it's good to understand the difference between these two behaviors, and that determinism is actually really, really good for games. So I talked about RAND as being the old way of doing things, and that's because it has some problems. My main issue with RAND is its distribution. So when you generate random numbers, ideally you can control the distribution. Sometimes you want random numbers, most of the time you want random numbers that have a uniform distribution. So every number within a certain range is equally probable. That's uniform. But sometimes you want a different distribution, maybe like a bell curve or something. Those can be useful. But for RAND, it generates a uniform distribution with a certain range. So RAND, let's see, rand goes from 0 to some max value. It's at least 32,767 according to the C standard. It could go more than that, but let's just assume this is the range. So it picks some random number between those, but what if you want a larger number? Can you go beyond what it gives you easily? If I was multiplying, if I was like, oh, well, I'll take whatever number it gives me and just multiply it by 1,000, then you're gonna get some really awful numbers that always end with 3 zeros. It's gonna be awful. There's not a great way to extend that range so well. Also, if you wanted a smaller value, how would you get a smaller value? There's a common way to do this. If you did, let's say, I'll do it on the second one, smaller value. Okay, so there's a common way using the modulo operator. And if you said like, all right, let me do 10. So rand mod 10 is going to give you the remainder after integer division. So it's going to give you a value between 0 and 9. So if I actually wanted it between 0 and 10, I'd have to make this 11. And that does restrict the range. That's useful. And if I wanted negative values, I could just subtract from this range or whatever. The problem, though, is that modulo is not really meant for this kind of operation of restricting a range uniformly. This messes up the distribution. So it ends up where smaller values closer to 0 become more probable after you do this modulo operation. And that's not really good. If you want to make like a D&D game or something, you don't want your players getting more low rolls than high rolls. You want them to be uniformly probable. That really stinks. Another issue with rand is that there's only one rand. There's only one generator. So if I wanted separate generators for two different systems, I can't really do that. I can't have two deterministic generators that I pull numbers from, at least not in a simple, obvious way. So say I want like the order of some unrelated random things to be independent from each other. Like if you have some visual effect, some random effect, and you have this random stat bonus that's given out, maybe you don't want to worry about the visual effects happening first or the stat bonus happening first. You don't really care which order. You don't want them to affect each other. You would like to have two separate generators. And that would help you to keep certain systems be self-contained. And rand isn't designed to do that. And then the last thing I care about, I guess, for rand is that it is absolutely not for high-stakes uses, especially cryptography. So the value pool, like this 0 to 32,000, is just too small, and it's predictable. It's not just deterministic. It's not just that you can predict it based on determinism, but if a hacker knows the algorithm that's being used, which is pretty well known for these different compilers, if they know the algorithm being used to generate numbers, well, you can just then look at a few of the last numbers that were generated, and then you know exactly which numbers are coming up. So you could do some bad stuff in games, like, let me just walk in and out of this building a few times, and then I'll know that a shiny Pocochub has spawned or something. It can be pretty exploitable for video games, and especially for online multiplayer games. It could be good if you want this specific avenue for exploitation, like if you actually want people to actively hack or manipulate your game. Sometimes that can be interesting, like if you're doing you want speedrunners to be able to use random number generator exploits. That's a thing, I guess. All right, so Rand is okay, but it's not good. There's a better option in C++. So let me get rid of a couple of these and we'll look at that. All right. So for a better thing, let's include random. So the random library gives us access to several different built-in generators and a different style of making random number generators. So one of those is called a Mersenne twister. And this happens to be in the standard namespace. There is an MT Mersenne twister 1993 blah blah blah. So this is Mersenne twister, but these numbers afterward are just something about the values that are being used for the generator itself. So not really important, but it's a standard like input parameters for this particular generator. So let me just call this generator. So I can make a generator and I can seed it. I can do the same thing as I did for before. I don't love this way of seeding things, but there it is. I could do that. And then when I want to get a random number out of it, I will specify the distribution. So let's say a uniform int distribution. I have to say it's using the integer type, and I'll call it, let's see, int dist. And then I tell it the low and the high values. So this is already much nicer. I can say like -5 to 50, and those can be the values that I go between. And it will guarantee that I get a uniform probability of any value within that range. And then I can use that distribution to generate a number. Let's see, since I'm already using random number, let's go for that one. So it's int dist, and give it the generator. Okay. So a few more steps, which is kind of annoying, but it's not that bad. But what it does allow us to do is that we can have separate generators. We can have multiple of them. That's great. We also have better control over the distribution that we're getting, and we can specify the range, which is much nicer and easier to read than trying to mess around with weird syntax there. And we can generate all the numbers that we want, like this. We can also use it to generate floating point numbers. So let's do like a uniform real distribution using the float type. And let's say float dist, and I can say whatever I want. Let's do 0 to 1. It's a really useful range of numbers. And then we can get some random float from our float dist. There we go. And the generator. Cool. All right. So then we can generate some random numbers that way. That's nice. And like I said, it's kind of annoying to have to like set up all this stuff, which is why I wrote some code that kind of does it for you. So if you have access to this file, random.h, or if you just want to look at it on the video here, it is a random class that has includes the headers it needs, and it has this generator that's part of the class. It's in the private region, so it really doesn't need to be touched. There's also this thing. This is a relic of how the standard was adopted. This random device thing, avoid it. Doesn't work on most platforms, so just leave it. All right, and then the public interface. We have a constructor that initializes this random generator and seeds it. So it's somewhat non-deterministic, and you can seed it yourself if you want it to be deterministic. That's cool. And then you have two functions, integer and float, that you can use to generate these numbers just like I did in main. So I have this file in my project already. So I will add yet another one of these. This time it's a file I'm providing, so double quotes, random.h. And then I can just make a random object using that random class, and I can get values out of this. So let's say I want random number rng.integer. So from 0 to 10, sure. And I think this is exclusive, so I think I would get 0 to 9 here. So let's do 11. And then we have our rand float, which I could use rng.float and get some other value between 0 and 1. And there, that's pretty nice to use. The thing you want to be careful about, though, is don't just create a random number generator right before you use it. Instead, create your random number generator and then use it many times. If you have multiple objects that need to use it, just pass it around. Pass it as an argument to the functions you need it in, instead of putting it right in there. So I would make a function like do random thing and provide the random number generator as an argument. And then I can do like make something. Right, this would be much better, passing it in instead of creating a temporary random number generator here and then doing what I need with it and then leaving. That way I can be sure that if I make a whole bunch of random numbers in a row, that they're going to have distinct values, instead of perhaps if I do this, if I call a function that's poorly designed, like this one. Let's see. If I did this, and I called this, there we go, and I called this repeatedly, if I called this a bunch of times in one millisecond, it might be that my random number generators all get seeded to the same value, same starting value, and then each time I ask it for another value, I'm getting the same exact one. So that would be terrible. Don't do this. Bad. All right, and then I just need to call that do random RNG. There we go. So that's it. That's your tour of random numbers in C++, and I will see you later.